Welcome to lecture 10, where I'll be talking about CarPaint. I'm sure you have waited for this lecture to start, but I had to brush up on the basic shaders before we go into the more advanced shaders. So a CarPaint shader is actually very complex because it consists of several different layers which are all tied together to create realistic shaders. Just to show you a little bit introduction how it's actually set up, you can see that it's made of a base, of a spec, and of a coat. The base has a transmission parameter as well, and the specular has pigments as well, so flakes to modulate some metallicness to the car paint. And on top of that, you also have a coat parameter to create nice and glossy reflections. So let's just start off by creating an AI car paint shader, hitting my sphere and assigning this to my sphere, and start the render. With the default shader, you get a default red car paint. It's nothing special, it's just the most basic car paint you will get. It's just a coat of diffuse red color, and then on top of this is a coat, which gives you the shiny impression. So on the interface, you can see it's also separated in base, spec, and flakes and coat, which is similar to this, just upside down. So the base is in the top, which is actually the bottom. Then you have spec, coat, flakes, and coat. So this is the setup. We have the sun coming from the top right, so this representation is pretty accurate, what I have here on the left. So obviously the base would just affect the diffuse of the car paint. So if I would change the color to maybe, let's create a blue car paint shader. By changing the base color, you can see what's going on here. The roughness is just distinguishing between two shading models. One is a Lambert diffuse, and on one it's a Oranea diffuse model, or Lambert diffuse model actually, which simulates more rougher surfaces, whereas the Lambert is a typical Lambert surface. Then you have specularity and you have coat. So on default, if I disable the coat, which is the topmost layer, which is the shiny layer, you should still get something reflecting below that surface, because a typical diffuse paint has also some shininess to it. So this is modulated with the specularity, and you can definitely change that. If you have like a rough paint coat below, which is more like a dry thing, you can definitely do that as well, and then play up the coat again to get a really, it's almost looking metallic, but it's not really physical accurate because you would not have this effect. So let's talk a bit more about the specular pass. So let's say you want to create a metallic car paint, and by default how car paints work, they have a base of diffuse or just regular paint, then they have a layer of metallic paint which is not 100% dense, so you would always see some diffuse shinings through it. So let's say I want to bring in some metallic paint. Let's just bring up the IOR, the index of refraction of the surface, to a higher value. And now you can see it's kind of a mixture between diffuse and metallic. So if I change my color to an orange, you can see the diffuse is still coming through there. Currently we have a white metallic color, but we would want something to be reflecting blue as well. So we kind of choose the same color to get a more metallic reflection response. So you can see that the specular color is tinted blue as well. So the next step would be to increase the roughness and see if we can get a nicer ping here. And you can see already now we see a very interesting looking surface from the get-go. The only thing which we are missing is the coat. So if I bring in the coat, you can already see now we have a nice blue car paint, and we get this nice little sheen on the highlights there. You can definitely play around with the roughness some more to give it a more broader sheen. And you can also bring up the IOR a bit more to create a stronger reflection, metallic reflection. So this is kind of the basic to create car paint, like a metallic car paint shader. What you can also do is introduce some flakes. And flakes is like little metallic pigments which change the lighting angle when it hits a light. By increasing the density, you introduce some flakes. So let's go maybe with a density of 0.5. And you can now see what this brings us. It is very dense, so we can definitely play around by lowering the density maybe to half, and you can now see we get these white flakes everywhere. You can also just color correct them. So if you want to have blue flakes as well, this is kind of the effect which you will be getting. And this is something you would see in real life. CarPaint, metallic CarPaint would look exactly like this. You get these really hot pings, and then you get this nice fall off of some flakiness to this. Obviously the scale would change the sizes of the flakes. I think it's currently in physical scale, but I'm not entirely sure. So you can actually see what's going on if I bring up the scale, and you can see, let's say I add another layer of flakes, you get more in-depth. These layers get added in kind of a depth way, so they actually modulate the proper thickness to this as well. And you can, the normal randomize is how the flakes are angled towards the surface. So on 0, they actually are not randomized on the surface. As you can see in my reference image here, you can see how each flake is bent differently towards the sun. And on a value of 0 would mean it would be totally flat. So if I introduce more randomization, you can see that the flakes are bending more and more towards the surface, towards the camera angle, and you can see a bigger differentiation of the flakes. And obviously, if you want to play up the density, just do that by increasing the slider. And the higher you bring in the density, the less you would see of the transmission in the end. So if I would bring back the scale to the default value, and if I change my base color now to red, we should only really see it very subtle around the edges. And you can see the red is really subtle only around there. It's just because the flakes are so dense. So if I would reduce the density some more, you can see that more red is coming through. And a typical CarPaint shader, you would still see the base diffuse color. It's just about realism. It's not that visible in the render itself, but it's just to modulate a correct surface like this. So this is touching up on the basics of the CarPaint. You also have a few presets. I'm not sure if every DCC has these settings, but let me just quickly just jump through here, and you can see what we get with the presets. So this is just a metallic blue CarPaint. This is metallic blue and flakes with kind of grayish white flakes. A brown metallic car. And then we have a typical red, which is the default, and a typical, oops, what did I do here? And a typical yellow CarPaint as well. So these are the basics. So I want to brush up on one more thing, which is the flip-flop color, which is kind of a facing angle reflection color. And we also have light facing color. So two things which are actually important to talk about. How the flip-flop works. It expects a texture which is based on the facing angle of the surface. So to create that, just create a facing ratio node like this. And what you can do then is connect this up into any ramp. Let's say a texture ramp in this case. And just connect the out value to my V coordinate. And then connect the out color to the flip-flop color. So I will show you what it's doing let's see if it's actually doing anything at all. Let's update the render quickly. I think we need to specify a color right here. Okay, so we just need to put in some colors. So let's say we want the edge reflection color to be maybe a blue, and you can see something is happening already on the edge right there. And we want the center color to be maybe something more towards a purple pink color, something like this. And you can see the edges are being tinted, but not as much as we would like. So because it's plugged into the specular and we expect it to be metallic, we need to increase the IOR. And by increasing it to 10, you can already see what's going on here. You have a purple center core, and then it shifts toward the blue. Let's bring in some more roughness, maybe 0.5, 0.4, and you can see now the effect going on. You can definitely play around in the facing ratio node with the gain or with the bias to get a more interesting result. And then you also have the light facing color, which is something whenever it's on a light surface, when the light hits the surface, it modulates a different color. This is typical for pearlescent CarPaint. So if I would change my light facing color to maybe green, and if I these two, flip-flop and light facing color, are controlled by the fall off. If it's on 1, it means it's fully the flip-flop color, and if it's on 0, it's fully the light facing color. And you can see, if I put this to 0, you can see that it gets really green where the light is. And if I slowly introduce or go back to 1, you can see it's kind of blending now between those two colors. So there's green here and there's green right there. So this sums up the CarPaint shader with the most basic features. If I break the connection and let's just head over to a typical black and blue, you can see now this is our CarPaint with the default settings IOR of 6, roughness of 0.5, and a density of 0.4 on the flakes. So if you want to go more in detail about this, there's lots of information on the Arnold documentation. And be sure to actually go the extra mile and plug in a bump map into your code which modulates surface roughness or surface tension. You can add some more dust layers, and you can really go a long way with this shader. It's very interesting, and you can do lots of different effects with this.